Hello, my name is Dave Marshall, and today I'd like to talk to you about reactionary forces and how they apply to simply supported beams. When you're done viewing today's lesson, I hope you understand what a reactionary force is, the difference between a pinned and roller connection, assumptions we make when placing reactionary forces, and what a negative number means in your answer. In this diagram, I've drawn a simply supported beam with a pinned and a roller connection. The pinned connection is sometimes called a fixed connection point as well. A pin support supports the structure in two directions, the X and the Y, and a roller support supports the structure in only one direction, the X or the Y. A pin support will have two reactionary forces, one representing the X value and one representing the Y value, and a roller support will have one reactionary force, representing the X or the Y value. Back here at our simply supported beam diagram, we need to now replace the fixed or the pin connection point and the roller connection point with reactionary forces. When drawing your reactionary force arrows, it doesn't matter which way the arrowhead points. Our formula, if it comes out to be a negative answer, will tell us that our assumption is wrong. So if we drew the arrow pointing up and our answer came out negative, that means the arrow direction would be down. We must remember we're doing static calculations, which means nothing is moving. So if we have a force applying in the y direction and it's 525 pounds on our simply supported beam, we must have a reactionary force holding that beam up that equals 525 pounds. So at this point, let's put a force on our simply supported beam. The force is 525 pounds and it's at point C. So FC equals 525. Notice points A and B. A is the pin connection point and B is a roller connection point. And I've labeled the reactionary forces RAX, or reactionary force at point A in the X direction, and reactionary force at point A in the Y direction. And if I go over to point B, I put reactionary force at point B in the Y direction. Let's do our moment calculation now. I always tell my students to always start with the fixed connection point. Let's write the formula. Sum of the forces around point A, which is the pinned or fixed connection point, must equal 0. Notice I've drawn a little negative sign with a clockwise rotation arrow above it. That reminds myself that clockwise rotation is negative. Remember, we're doing moment calculations, which are turning or torque forces. So, if we look at all the forces that affect point A and make it rotate, we've got point C and point B. So let's start with C. FC is 5 feet away, and it's a clockwise force, which means it causes rotation clockwise around point A, so that's why it's a negative, plus negative RBY times 10 feet, and RBY also causes a clockwise rotation. If we now substitute in our knowns, negative 525 times 5 plus negative RBY times 10, set that all equals 0, we'll get negative 2,625 plus negative RBY times 10 equals 0. At this point, we want to get the 10 feet away or get RBY by itself. So if we divide each side by 10 feet, the 10 feet cancel out on the right and the feet cancel out on the left. So I'm going to have to divide 10 by negative 2,625 and I get a negative 262.5 pounds plus a negative RBY equals 0. Again, I want to get RBY by itself, so I'm going to add a positive RBY to the left side of the equation and add a positive RBY to the right side of the equation, and I get an answer of negative 262.5. RBY equals negative 262.5. What does that mean? The negative sign means that we've drawn the reactionary arrow in the wrong direction, so we'll need to go back to our free body diagram and draw that arrow in properly. In our initial assumption, we drew the reactionary arrow pointing down. Our mathematical formula came out to be negative, which tells us that we need to change this reactionary arrow. This reactionary arrow needs to be pointing up. This just goes to show that drawing our reactionary arrows and making our assumptions, it will all work out in the end with our math formulas. If our math formula tells us something different, we'll just have to go back to our free body diagram and make those adjustments. So if we look at our lesson objectives, hopefully at this point we understand what a reactionary force is, the difference between a pinned and a roller connection, assumptions when placing reactionary force arrows, and what a negative number means in our answer. If not, go back to the lesson and review, and then come back and look at your lesson objectives again. Hope this video lesson helped.